And hopefully we can work with that. So let me give you some time to read the question number 1 and to pick an answer. Okay, I'll just read it, but I will not pick the answer first. If you can, please, can you put into the chat messages for me, what do you think the answer is? Okay, just A, B, C, or D. Suppose x and y are integer variables, and we form the sum, x plus y. Next, suppose A and B are the decimal numbers, right? Okay, typos, decimal numbers. And we're using the type double for them. And we form the sum A plus B. The two plus operators here are clearly being used for different types. This is an example of what, right? Choose from the following options. So consider the answers, and can you please put into the chat messages for me, what do you think the answer is? I need your answers to see where do we stand, right? How are we doing? Do we understand what they're talking about? Or maybe have any discussion, why that answer over the other one? I see the answers are coming in, right? And you can see them as well. Mhm. I want a couple of more answers to see, what everybody thinks. Because I want to discuss the ones that are correct and the ones that we picked, and they are not correct. Mhm. One more answer, somebody. One more answer. Come on, 16 people are attending. Well, okay, excluding me, 15. And I see only 6 answers. Come on, make a pick. Pick something. Okay, it's nice. So I have a good collection of answers, and they are mostly concentrated about B and about D, right? Now, the correct answer here is B. So this is an example of operator overloading. Let's talk about why it is not D, right? The type inconsistency happens when I define a method that works on integers and I'm trying to apply it to the decimals, right? That will be type inconsistency. But here, they didn't say anything about that operator being already defined, right? So no, they're saying that we are forming the sum, right? So they do not say that, hey, we already defined how to add up two integers, right? That's why the D is not. The D is you're right, it's on the way, yes. If I define operator plus on integers, then I will be in trouble. I will have type inconsistency. You're absolutely right. But this is if I will already defined it, right? So the operator overloading, he'll be more a general one, general answer, because what it means is in order to tackle this two different forms, right, of sums, we need to have operator overloading, right? Operator overloading. Okay, excellent. Now let's go to the item number 2. And then I'll also show the item number 3 for you as well. Okay. I just realized that I didn't put the answer selection over here, but it's okay. I'll do it for the rest of the problems. Now, number 2, assume that my array is a non-empty built-in array of integers, like the C-style array, right? Not the C++ style, right? The one that we include the header array and we use the template, right? We say how many elements and what type. Now, how can I find its size? In other words, the number of elements in it. And here is a hint for you. We had a function that returned us the size occupied, right? Like size in the memory, how many bytes, right, are used. So try to come up with the function, try to recall what is it. And once again, it's just like you kind of have to recall, hey, we had it, and you will, start looking through the examples or something. So it's a good place to review it. Now, the number 3 is about the inheritance. So that chapter that we had about the inheritance, the question is from there. When deriving a class with public inheritance, remember we had the choice there, public, protected, and then private, right? Public members of the class become what members of the derived class, right? Or child class. And protected members of the class become what type of members of the derived child class, right? So we need to fill out these blanks, and it's all about public, protected, and private, right? So it's all about that. So try to think of the answers to both of the statements. Let me see the chat messages. Yeah, okay, yes. That's correct. Okay. Yeah. Uh-huh. Not quite. Okay. So while you're thinking of them, I am replying to the chat messages, right? So put the answer to the 2 and 3 into the messages. I'll be replying to you, but once again, I also want to see how we are doing there. Like, do we remember? I know that you didn't have a preparation here, right? But I wonder if you remember them. Okay. Okay. Now you can put the answers to everybody so that everyone could see it. It's actually very good experience. And I will be replying in private messages to you. Okay. So the hint for the number 2 is you will be using the operation size of. Let me put it in. Size of. You will use size of. I think it's a lowercase size of function, right? Now the size of function returns you the space occupied by this particular variable, right? Or if we have the array of integers, how much space does the array occupy? But this space is in terms of bytes, right? How much memory. So we need to figure a way to find out how many elements in it, right? Yeah, I'll give you just a few more minutes, like 2 more minutes, and then I'll put the answers up. Okay, so excellent, excellent. I have some answers and I can work with them. So check this out. Let me modify this one. I'll extend it. Okay, so the best answer here will be to say C out. You know, you can omit it. Okay, it's not a big issue. I will not be taking any points off. Then you say size of my array. Now this statement will tell you how much space your array occupies, right? And then you divide it by the size of first element in the array. You see what's important here is that it's not empty. It's good because if I know that it's not empty, then I can grab the size of the very first element there, right? My array at the position 0. You know, 0 is safer because what if they have only one element and not the second one, right? So you cannot, you know, and you would ask the 1 here, right? So 0 is safer. This will guarantee you that it will return you how many elements are there. Because, for example, this array occupies 64 bytes, right? And each element occupies 4 bytes. So you will be dividing 64 by 4 and you'll get whatever it is, 16 elements in the array. So this is the best answer there. Now, why does the function, okay, correct. I'm answering the chat messages in parallel. Why does the function call won't work? This is what I mean. So if you put my array dot size, my reply would be it doesn't have it. It's not the C++ style array, right? So the C++ style array, the one that we do with the template, it does have it, but not ours. Same thing about this, my array dot size of. It's not working like that. So it doesn't have it either. So these two items will be incorrect, right? So not these answers. Okay, let me see the chat messages. Yes, size is used with the vectors, John. Yes. So with the vectors, with the C++ style array, like with all those containers that we have right there, cooked up for us, right? But the built-in C style array doesn't have it. Okay, now over here, the answer will be public members will be public and protected members will be protected. It's like the easiest case over there we always use that. That's why I put this question only. There are other possibilities out there. We had a table in the textbook, you know, just if you ask the question, you can quickly refer to the table, but we were only using the public inheritance with you, right? So let me put the answer here. So here it would be public and here it will be protected. Okay. So yeah, so the answers that I saw, they were all correct, right? For the question number 3. Close. Oh my. Sorry, I'm still getting the messages. But let's go to number 4, unless you have any questions. So let me know if you have any questions. And if you don't, then we'll go to the number 4, maybe 5. Yeah, we can do 4 and 5. Should be able to fit into the screen. You know what? It's snowing outside my window. It's like really, really tiny, but I believe it is snow. Well, anyway, it will melt, but it's nice. I wish we would have it for Christmas. So let's go over here. I'm using the wrong tool. Here, check out these 2 questions. The question number 4 comes from the was it in the inheritance when we use the virtual functions? Was it polymorphism? I don't remember exactly which chapter it comes from. So it might be from the inheritance. It might be from the polymorphism. You know, I think that it should be from the polymorphism, but I might be wrong. But we used to use the word final there. It's for the class and it's for virtual function. So it's like 2 things that you should be listing here, right? And then in number 5 here, write a C++ statement that will output or display the address stored in the variable myPTR of type int store. Yeah, so you remember what we had from time to time is somehow I could just print out the value of my PTR and it will display me the address, but sometimes I couldn't. I don't remember the situations. We did have the situations when I couldn't. So I had to use the reinterpret cast command. Remember to typecast it, the pointer from int pointer to something else. So try to recall what was it. And once again, you don't need to remember all of these things right now. When you will be reviewing, just make a note, for the items similar to this. Hey, I'm doing this and I'm doing this. I know that it's a lot of information. You are keeping the book, then you can use the highlighters. If you don't keep the book, then you could use the pieces of paper, but it will be a good amount of them, right? So anyway, just kind of pointing you in the right direction here. So I'll give you a few minutes to think about it. Let's think about it for 3 minutes, and then I'll put my answers there. I'm not asking you to put the answers into the chat messages, but after I put mine, if you have any questions, let me know. Okay. Resume the recording. Okay. So in number 4, 2 things about the function, and let me use the tool. Okay, so a base or parent class virtual function that is declared final in its prototype cannot be overridden, right, by any of the derived classes. So first thing, right, a base, we call it sometimes parent, right? So a base class virtual function that is declared final, right? Usually we do it in a prototype, right? In its prototype, right? Cannot be overridden. So it's like final version of it, right? Overridden by derived class, by a derived class, or by any derived class. So this is the first thing about the keyword final. We can use it for the virtual function. Let me check the chat messages. Let me close this. Number 4, would it be deriving class? Number 4. Derived class, yes. So yeah, so Dale, once again, it's about the derived classes, right? So if in the base class, I said that the virtual function is final, right? Then in the derived class, I will not be able to override it. Okay, yes, Ricardo, yes. So yes, this is an example, right? Yes, that you have there. Okay, now if I say that the class is final, what does it mean? Remember? So when I say the class is final, what does it mean? It cannot be the base class for any other classes, right? So it cannot be the base, or parent class, right, for any class. So we cannot use it, right? We cannot use it to be the parent class or the base class for any class from now on, right? So we cannot inherit from it. It cannot be the base class for any other class, right? For any other class. Okay. Like this. So we're preventing, anybody else to use it as the base class. Okay. Doesn't always work. Right. Okay. So the answer to this statement number 5, the easiest thing, okay, let me check the text message. So the easiest answer here would be to say cout, my PTR. And in some of the cases it does work, but in some it did not. So I remember that we had to use the reinterpret class. doesn't work in some cases, but doesn't work in some cases, right? So in this case, what we have to do is we have to typecast it to the void pointer, right? So this is what we will do. We will do, and it's called, has to be reinterpret cast, reinterpret cast, because these types are not close to each other. We have to cast it to the void pointer, and only then we will be able to display it. My PTR. Okay, so in this case, it will be showing you me, the address. Okay, works, right? Works. I'll try to find the example where we couldn't, because I remember there was, maybe it doesn't work for the user-defined classes, maybe, right? So it works maybe, so maybe this one works for the built-in classes, but doesn't work for the user-defined classes. Don't remember, I'll have to look for it. You know what usually I do is if it doesn't work, I stick to the second one, right? Reinterpret cast. Okay, but should be working. In this case, it should be working, right? So, and I think that this question is actually from the pointers chapter, what it was, chapter number 8. So it was actually participating in the midterm exam, right? It's not after the midterm exam, but it was a good example that I kind of recalled that we had. Okay, let me know if you have any questions. Okay, it is in, yeah, I agree with the comment. It's extremely a huge amount of things to memorize. Yes. Okay, yes, it's too much. What about the address of my PTR? Maybe it will work. If you've been using it and it works, fine for me. Address of my PTR. I'll tell you why I don't like the way it sounds. So the address of my PTR might give you the address of the variable my PTR. That's not what we want, right? So here is the picture. Actually, excellent question. Let me draw you a picture. So this is my PTR, right? My PTR. It has the address of 100, but it stores the address of 64. So it goes to some place where something is stored, let's say number 27, right? Now what we want to see is this number. What the address of, right, might return is this value. So if it's this value, that's not what we want. Okay. So that's what I want to say. Okay, any more questions? I muted myself by accident. Okay, whatever. Okay, yeah. Okay. Yeah, another issue is how to read the question, right? Okay, so here, then you know what? Stored in the variable, right? This points to this, stored in the variable. Yeah, like, we want to address all the things at this moment. So I'm really glad that you are coming with these questions. Okay, good to go. Let's proceed. Here. Now, let me see how can I make sure that everything is in the picture. Let's make it smaller. Okay, so here it is. Everything is fit. You know what? Let me do this because this might be also, yes. Okay, it was affecting also the screen. Okay, so check this one out. Consider the definition of the class my class and the definition of the function main. We'll read through it. Look at the question first. Always look at the question first. How does the value of static class attribute C change? So now you will know what to look for, right? State C's values after the stage 1, and you will know like what's the stage 1 and after the stage 2. Okay, so what we will do, and I think I'm missing some of the here, right? Okay, I'll fix it. So you know what to look for, something static and stage 1 and stage 2. Let's look at the main function first. What I see over here is that something is created as pointers, right? As pointers. So here is a pointer to an element of type my class, and it's created dynamically. Do you see this dynamic memory location, right? New my class, and here is the initialization for it, right? And here, so 3 elements, A1, A2, and A3. 3 elements of type my class were created, some names are supplied, right? And oh, here is the stage 1. Okay, so stage 1, and then the elements are deleted. Oh, you know what? This one is a typo, it should be A3. So let me fix it in place. Okay, so A3 here, A3 here. A2 and A3 were deleted. I cannot release the same element, right? Actually, by the way, I used to get error messages for that when I was trying to release it. Don't know how it is now. It should be the same, but things can change. So here, we are releasing the space for 2 elements, A2 and A3, and then we output the stage 2. Okay, so this is what they meant. So after the stage 1, state what's the attribute value, what's the value of the attribute C, and then after the stage 2. Now let's find that attribute C. I see it here. It's a static integer variable. Now, this is a question about those static variables, attributes of the class, and static methods. We did them. What chapter was it? You know, while you're looking at it, I'll try to find where we had it. Where is my book? Here. Static. Okay. Static attribute. But look at what's going on over here. I do have a constructor and I do have a destructor. Now, when I'm constructing an element, the C's value is incremented. When I'm destructing an element, right? When I'm deallocating it, the C's value is decremented. And let's see, what you also should look for is what's the initial value, right? What's the value in the beginning? Not here, not here, here. So remember how we had to go about them. We couldn't do the initialization and the definition. We had to do it right after, right? So we cannot initialize the static variables. I think there was some exception there. No, even the constants we did afterwards. Okay, so we had to initialize it here. So here is the initialization. Initially, it is 0. So take your time. Think about this problem. I'll give you 3 minutes to think about it. Put your answers into the chat messages. So put me the value of C after stage 1. So after the C out statement and after the C out statement. Okay. And I'll meanwhile find where it was in the book, what chapter. 3 minutes, 17 minutes now, right? Is it 17 minutes now? No, 43. Okay, 43, 46. Okay. Static, EQ stack. Okay, static data member. Okay, found it. PO4, 429. Tracking the number of objects. Okay, so it must be 432, 429. 429. Okay, you know what chapter it was? Chapter number 9. It was from chapter number 9. That's probably when we had it. I'm looking at this chapter number 9. Yeah, static class members. So it was chapter number 9, right? Let me put it here. Chapter 9, right? This is where the care question came from.
Non mi riesco a pesare.
Got to pause the recording. Let's resume the recording, okay? So once again, after the creation of the first object, right, of type my class, the C's value is incremented from 0 to 1. Over here, the C's value is incremented from 1 to 2. So we have 2 objects already, right? And then over here, the C's value is incremented from 2 to 3. So every time an object is created, the value of the C is incremented by 1. We have 3 objects, and therefore the value of the C is 3 because we started with the 0, right? If I were to start with 10, it would be 13, right? Okay, now, so after the stage 1, the value of the C will be equal to 3, right? Let's put it up. After stage 1, the value of C is 3. Let me extend it a little bit. Okay, now when we are destroying an element, it means that we are deallocating the space, right? Over here, what happened is that we allocated the memory dynamically. So if I use the statement delete and give the name of the object, it will, release the space. So the information is still written there, but we are not supposed to access it any longer. Now the A2 destruction will decrement the C value by 1. The A2, A3 destruction will decrement the value of C once again. So from 3 will go to 2, and from 2 will go down to 1. So after the stage 2, the value of the C will be 1, right? Let me add it over here. Come on. Did I lose my control? It's so weird. It doesn't allow me to grab the toolkit. And it means that my Zoom is glitching. Okay, and I do hope that you can still hear me, because if it's glitching, then sometimes it means that something is wrong with the connection. But you know what? I have Ethernet connected for quite some time already because I was having issues with the Wi-Fi. Okay, let me see. I can access weather issues. Exactly. That's that snow outside our apartment. Yeah. Okay, I got the controls back. Hooray. Okay. So after stage 2, the value of C is 1. Okay. So, if they ask you to give a general overview of what the C is doing, right, you will say, in general, when an object is constructed, the value of C is increased by 1. And when the object is deallocated, the value of C is decreased by 1. Or you could say incremented, decremented, right? Absolutely up to you. So C counts the number, let me move it up. Okay, here. So C counts, why don't you see it? Let me see, okay, now I see it. So C counts the number of objects, right? Of type my class, something like that. Let me move it. Or can I maybe like this, and then it will fit in so that you could see it clearly. Okay, so, this is once again, you might be asked in general, what is it doing, right? So in general, then you could say this message, something like that. Any rephrasing of it, just pay attention to details. What's important to state here is that it is increased where the object is created, and it is decreased when the object is destroyed, right? You could use the word destroyed, that's okay. What else? So Once again, review those static variables and functions. You remember that special thing about the static methods, that they can only access the static attributes of the class. It's also another important item to remember, right? Okay, just to review it. Okay. Any questions? Let me know. What is it? Number 6. So we have 2 more questions left, right? Questions left. Okay. I know that the next one is a coding question. It's okay. We'll do that one first and then the last one. Yes, I don't want to change the order of the problems. So let's continue. Let me clear everything up. Let me grab the mouse and let's go to the next one. Or this one. So, as I already, did I tell you? Yes, I did tell you. I did tell you that you had it as a suggested exercise. While you will be thinking of it, I can find what chapter was it as well. It's just only now I realize that for each question, I should have put a chapter that it is related to, right? So I'll do that. Now, all these good thoughts, they come after you need them. So, but anyway, it is rephrased, and it is exactly the case when you have to pay attention to the details, and you should not overwork here because you can easily do it. So here, look at this. Give an interface. We'll talk about this on the class polynomial. The internal representation of the polynomial is an array of coefficients. I have a typo, value at position I is the coefficient of the term with the variable to the power of I. So, in other words, if I have an array with 1, 2, 3, 4, 5, 6, 7 elements, right, filled out, here we see the positions, right? We can rephrase it as 12 times x to the power 0, negative 9 times x to the power 1, 0 times x to the power 2. That's why you don't see it, right? 4 times x to the power 3, 0 times x to the power 4, 11 times x to the power 5, and 5 times x to the power 6. The class should have a constructor and a destructor, functions get and set, and provide the following operator capabilities. Operator plus, that overloads addition of 2 polynomials. Operator minus, that overloads subtraction of 2 polynomials. Operator times, that overloads multiplication of 2 polynomials. Operator plus equals. This is the addition assignment, right? It's when we add something to our object. Operator minus plus, overloads subtraction assignment, and operator times equals, overloads multiplication assignment. The first thing to note here is that you're not asked for definition of the entire class. You're only asked of the interface. Interface is what we put into the header file where we announce that we have public functions, private attributes, right? And so forth. We are not required to put the definition. So if you were asked to do so, you would be told here, please put the definition of the constructor and the destructor and maybe some other method. So unless you're told specifically to do that, you will not do it, right? So when you're asked to define a class, it means that you need to do full work. If you are asked to give an interface of the class, it means that you only are expected to do a header file, right? So you don't need to do the definitions. And the reason here is that even this is a lot of work and it's a lot of design decisions here you will see that we'll have to make, right? So think about what you would start with. You can even write them out, right? So will you have a constructor? What should be the argument, right? The parameter of the constructor. Should it have it or should it not, right? What will be your attributes? Well, not your polynomials attributes, right? What would you use for the attributes? Obviously array, anything else, right? what the functions get and set should be doing, because it looks like we are only storing the coefficients. We are not storing the variables, because it doesn't matter what variable is there, right? I could replace the x's with the y's, with the t's, with the z's, whatever it is, right? So it doesn't matter. So we're only storing the coefficients. So in this term, what do they mean by get and set? And you see what they do here is they kind of leave the decision for you. They want to see what will you decide, right? So, and maybe, you know, along this construction, you will find that, hey, you know, it's good to have a definition of constructor and destructor. I have a comment for myself. I was also thinking of, yeah, like you see, if we are talking about the polynomial, should we get its degree, right? Because we always should be aware of what's the degree of the polynomial. Maybe it's another function that we can introduce, right? So something like that. So think about it. I'll give you 3 minutes to think about it. You don't need to think about it a lot because you need to kind of start working on it, right? So just a moment, a pause for you to absorb it, and then we'll go to the Visual Studio and we'll code it. Now, a good hint for you. Let me share the entire screen. Let me share the entire screen. I'll go to our webpage. If you recall, you had a homework assignment for the complex class, right? Complex. Square, no, complex. Why am I talking about complex? Because in the complex, we had to overload those operators. So look at the header that you have here. You remember I gave you the header. You can already, you know, see some of the things that you can grab. Like, you know, what's the return type? How should it be done, right? What are the things that you should mention over here? So you can definitely reuse some of the things from here, right? So feel free to do so. Nobody's limiting you. So even during the in-person exam, right, I'm not allowing to use any online resources, that's true, but I always allow to use our textbook and our website, okay? And, you know, the interpreter, right, the compiler. Not the interpreter, the compiler. Interpreter is for Python, right? So this one. So always feel free to use the files that I posted, right? Okay. So let me go back to this. I went over it here. Just a moment for you to think about it. So 3 minutes. Resume the recording. And once again, it will be a header file because it will be only an interface, right? And this one I'm erasing. I usually put the if not defined, right? How is it called? Polynomial.h. Like, you know, once again, so what some people do is that they put double underscore, then the H, and then another underscore. It's just the way of putting things up, right? I usually just put the H, but it's your style. It's whatever you choose to do. It's whatever your company wants you to do, right? So define, if and defined. Okay, yeah, define. Let me copy and paste. Define, and then and the if. Okay. Good. Now, no error messages. Now, class polynomial, right? Polynomial. It does everything for you. So immediately put the public in place and the private, right? It's like, you know what our teacher used to call it? It's like a skeleton, right? You're building some things in and then you fill them out, right? She used to call it fish skeleton. I don't know why. You know, I really don't know why. But it's probably a good association, like, you know, really like, you know, you have these bones in. Now, let me do the following. What did they say? Constructor and destructor, right? So you will put polynomial, and then you don't know what the parameters are yet in. And then the destructor, polynomial. And then you think, why do we need a destructor here, right? Like, why would we use it? Let's go back to the question here. The internal representation of the polynomial here, I'm looking at this one. is an array of coefficients. Okay, so you know what? If it's an array of coefficients, then we have two options here. We either use the template class from the C++, the array, or we use the C style arrays, right? The built-in arrays. And here is the decision. Arrays, C++ style arrays, they would take up a little bit more space, but you do have the size come with them, right? Like you have iterators come with them, and so a lot of built-in things. But what I think, at least for now, at least for this particular question, is we don't need that much of power, right? So let's keep it grounded. Let's have an array, the C style array here. Now, if this rings a bell, then we used to have an example really of array here in our class, Control F, array. We were covering them. Like, you remember how we were working on them, right? So while it is when we build the structure of the array, what we do use here is we use dynamically allocated memory, right? Check out how do we do it, right? So we had the constructor, we had the copy constructor. We will not have it here. We are not asked for. And we had the destructor. So we had the destructor because check this one out. This was size of the array and the pointer. And you know what you will do? You'll just grab it and you'll copy it. Where is it? Here. You'll just copy it. So this is size of the array, right? Of how many coefficients do we have? And then this is the pointer to the first element. It's a pointer-based array. And we will definitely use it, right? Now, you can go into the details of how did they create it. So this you could be putting into the constructor later on, definition, right? But check what they have here. It's a fixed size array, right? So although I will know the size at the runtime, and I can dynamically allocate space for that amount of elements, right? I need to put the size into the constructor. Now, let's go back. We are a little bit smarter now. So instead of int, since I'm using size t, I can put here size t, right? Or I can put the int. I can keep the int, not a big deal. I'll tell you why. We'll be checking whether the size that is provided is greater than 0, right? Greater than 0. So syntax is, so this is a decision that we took right at this moment. We need to know what will be the degree of polynomial, right? So in advance, when we are creating it, so this size, I will check to degree of polynomial, and I will change this one, degree, right? Degree. Let's see. Oh yeah, I used the same name, degree here. I think polynomial. Here I used a different variable name, but it doesn't matter, right? It doesn't matter. Who cares? Who cares? So this is the decision we took, right? That when the polynomial will be created, we need to know its degree. And it's reasonable because we cannot create like any polynomial, right? We need to know exactly how many slots will there be, right? Okay. Now, we do need the deconstructor for it because we will be deallocating elements. And if you are very kind, because you're not asked to do it here, but if you are very kind, you could actually put what the definition of destructor is because it's usually extremely simple. Check this out. Where is that CPP? CPP, find the destructor. This is constructor, this is copy here, this one. This is all, right? Now, since it's an array of elements, we need to use the square brackets. If it was just one element, it would be delete without square brackets. So let's copy this one over. I'll copy it with the comment, right? So over here, I could say this. Here. Here, like this, right? I could say this. And you know what we could do? If we don't want to call it PTR, we could say coefficients or polynomial, up to us, right? So we could call it coefficients. And here I'll call it the same name then, coefficients. We could call it coefficients array, right? Oh, sorry, wrong place. Coefficients here, coefficients, right? Because PTR tells me nothing, right? Really nothing. So the coefficients would sound better. The coefficients of terms too long. Polynomial could be okay. Okay. So array of coefficients, right? Something like that. Excellent. So we have these ones set up. Now we'll go back to the description. What do they want? Get and set. Okay, get and set. And then these ones, right? These ones. Okay. Get and set. Okay, so they should be public methods, right? So get, I don't know yet what, and then set. I don't know what, right? So now let's think about it. So we do have a list of coefficients. Now, what do they mean by get? One thing you should definitely consider is that it's not for printing. No, for printing, we will overload the outstream, right? Operator, that one, right? We will announce it as a friend function, right? And I will, I will redefine it, operator, that side, and so forth, right? So that's not for the printing the polynomial. To return a polynomial, it's also weird. I already have it. Why should I return a polynomial? So one of the decisions, that sounds really reasonable is to get a term that has a degree of I, whatever it is, right? So int here, and then what could I say? Ith degree term. Like, something like this, term. Ith degree term, right? Ith degree term. I think in my, implementation, I just called it position, right? Position. But maybe this one tags better. So returns the coefficient of the term with the given degree, right? Given degree. So something like that, that we could use. Now, if it returns a coefficient, then now it's time for us to decide what would be the type of coefficients. Should it be integer or should it be double, right? Because you see what I don't like about the integers. Integers are too limiting, right? I think it should be decimals, right? So if I do this, then I will say here that it's a double. And then I should change this type to the double, right? So if my coefficients will be, I'm allowing for decimal numbers to be there, then I should change this type to the double pointer. Now, nowhere in this description it was said that I have to stick to something. If you decide integers, fine with me. You will not be taking any points off because once again, that's your design decision, right? So you are judged on something else, right? Not on this one. Graded, judged and graded, right? Okay. So looks good for now, right? Looks good for now. So now keep in mind, if you are asked to define the constructor and destructor, you'll define them here. I'm not, I don't think that it will be taking too much space. We only announce the degree. The good design decision would be to fill out all those spots with the zeros, right? It's like, initially the polynomial is degree of that, but it doesn't have any coefficients yet, right? No coefficients yet. Now then, in this case, set function will take care of it. Similar to the get, it will be modifying the coefficient of the positions term, right? So let's do it. Boolean, I need to return Boolean. This is another thing. I will return true if everything is okay, and I will return false if the operation is not possible to perform. Like, for example, I have a degree 5 polynomial, and they are trying to change the coefficient of the term with the degree of 6 or 7. I will return false, right? Obviously. So Boolean, this one, it's a good design decision here. And then int ith degree term, so the position at which to change it, and then double value, right? Coefficient value. Okay. So let me put the comment for this function. We will keep it separately. Okay, changes the coefficient of the term with the degree degree term to coefficient value. Okay, if possible. Otherwise, and returns true. And returns true. Otherwise, if not possible, returns false, right? Once again, we're making it foolproof, right? Okay, something like that. Like that. And you know what? Since it's running out of the screen, what I could do is I could just put it above it, right? Like this, so that it would look nicer. Okay, we got get and set methods. Now what to do with the rest of the methods, right? Here we have this bunch of the operators. And, you know, since I pointed you out to that complex number, why don't you just grab the operators from it and then change them, right? So let's go here, not the array this time, but the complex number. Where is that header? Here, found it. Grab these functions. We'll have to change all the comments, and we don't need the division, by the way. So we'll do this change, right? So first of all, we do not need the division, so let's delete it. Okay, we only need this 3 and then these 3. Now we are working with the polynomial, so we are replacing all the appearances with the polynomial, right? Polynomial, and then I'll go over them. Like after I do the replacement, I will definitely review all of them. Okay, polynomial. We're adding 2 polynomial functions, right? Polynomial. Okay, you know, these comments, let's delete them. If you have time, you will put the comments there. But since these are standard operators, you don't need to put the comments for them as we did in this case. So you see, these are not standard ones, right? Like, you know, standard names, but they get each separate interpretation depending on case to case. These ones are quite clear what they do, right? So this operator adds up 2 polynomials and it returns the new one, right? That's why we have just a polynomial here by value, right? We could return a reference to it, but it's not really good because we are creating an object inside the function that just terminates its existence later on. So it's better to return it just by value. Now, this operator should not be changing any attributes of this object. But what I want to say is that it shouldn't change the other object as well. So I should add const here, right? So we didn't have it in the complex, you know, because we just didn't consider it, decided not to do it for the time being. But this is true. So it should not modify the other polynomial as well, right? Now, what we can do in this case then is we can provide it by the reference to save the time, right? So we can provide it by the reference over here. This const will prohibit, right, the modification. That's exactly what we use it for. So when we send the polynomial by reference, we put sure, you know, we make sure that it is passed as a constant, right? So we cannot modify it. Why don't we do it here as well? So I can do it here as well. I'll pass it by the reference because it will save me time and space, right? And we can put it over here as well. Okay. Now, these operators, it's assignment operator. So what it does is it grabs this other polynomial and it adds it, not appends it, but it adds it to our current polynomial. So I shouldn't put the const over here, right? It will be changing the attributes. It will be changing the attributes. I think this is it. I think we're finished. I think we are finished. We are really finished because we did this, we did this, we did these functions, and we did these two, right? So the only function, function that I might think of is when we return size t get polynomial degree. This is another function that I can think of. I wasn't asked for it here, right? So for example, if you have a question, what another function you think, makes sense to add? Definitely this would be the first one that would come to my mind. Maybe there are other ones, right? But returns the degree of the polynomial. Okay. Something like size t, apologies, size t. Something, like that, right? So it would return. It will be also constant, right? So it should not modify. Same over here, constant. So whenever I can, I should add that the function is not supposed to modify the attributes of the class. For example, set is not a constant, right? It will be modifying it. These will be modifying it. This will not, those will not, right? Something like that. Let me see. Do I have any other comments for us? No, I don't have them. That's it. That's it. Now, don't pay attention to these green underlinings because it means that we need to put the definition, but we are not working on it, right? We are only working on the interface. Okay, so then in this case, this will be it, right? I'll put the solution after our class is over to our web page so that you would have it, right, for our today meeting, this one. I don't remember if we had a code for here. If we had, I'll put it too so that you could see it. Okay. Now, let me know if you have any questions related to this program. It's not a program, okay? It's just an interface. Okay, so you are either lost completely to me, or maybe you get everything. Okay, or maybe you're kind of somewhere there, almost there, right? But I do hope that everybody is in the part somewhere there or got it completely. Okay, so let me save it and let's go to our last question for today. So once again, it's misnumbered, it should be 8. And let me scroll it up here. Let's see. So we will be having a question similar to this. Once again, not guaranteed, right? You could have a similar one, right? Yeah, we'll call the lecture again. Yeah. So, it's not guaranteed that you will get the same one, right? A similar one, maybe. Slightly changed, for example, you might be given something like an interface already, and you will be told to write the definitions of the functions, could be, right? So once again, I cannot give you like exactly that, yes, it will be similar, just numbers changed, right? Like in math. No, right? But it is around this, creating classes, defining them, thinking about the functions and so forth. Yes. Okay. Now this problem, where is it from? I think it's from algorithms that we had it, that we had that chapter of algorithms. So I think it's coming from that one. So consider a vector my_v filled with integer values and the definition of the function my_function. Here is the definition. Now the question A is, what does the following code do? You'll have to recall what does the algorithm count_if do, right? Now, obviously, remember the function of the algorithm for each, right? So looking at the first two parameters, what you can predict is that it will be iterating over all the elements of the vector object And looking at this, it's just the name of the function, right? It's just the name of the function. So what it means is that this function will be applied to every element in the vector object, right? Okay, so now what we used to have here as example is lambda notation, right? Lambda expression. And here I'm only using the function name. So it will be function applied there. It's lambda or function, you know, it's one of them. Okay, and then count is, this count is displayed. Okay, and then the second question, what would be a value of count variable if the vector my_v is filled with numbers from 1 to 13, right? So then it means that you'll have really to understand what's going on in this function. So this one is a general question, right? What does this code do in general? And then this one is given an example. So if the vector is filled with the numbers 1 through 13, what will be the value, right, of the count? Now, yeah, so John has an answer here. Let's discuss it right away. So prints out the elements that are divisible by 3. It will not print the elements. But you are right about divisibility. You're absolutely right. But it will not print the numbers. What will it print? Right? Good beginning. I'll keep it over here. Okay. And I'll ask you to, we'll see if it's true or false. This one is yes, this is what the function will do, but what will be the count here? Right, what will be the count here? That's the question. I'll hide it because everybody could see the chat messages, right? So think about it. I'll give you 3 minutes. 3 minutes, okay, 4 minutes, not more. And if you can please put the answer to the item B for me, right? B for me. So don't do the A. A is overall. We'll put some blurb here, some text. But can you give me the answer to the B in the chat messages, please? Okay, and let me do this. I'll be sharing only the lecture slides with you because we don't need to do the Visual Studio, okay? So 4 minutes for you to work on this question. As my timer went off, let me tell you what the count if does. Count if counts on how many elements the function my function returned true. So you were all, you know, those people who put the answers into the chat messages, you were all on the right track. Indeed, my function returns true if the value is a multiple of 3. In other words, divisible by 3, right? Now it returns false otherwise. Now the algorithm count if will run the loop from the very first element in the vector to the very last one. And it will run the function my function on them. So if the value in the vector is divisible by 3, it will be counted. It's like a counter here, right? If the value is not divisible by 3, it is not counted. So in other words, this function count if will count how many numbers or values in the vector my_v are divisible by 3, or how many of them are multiples of 3. That's what will be displayed, okay? So in the answer, you will say that the number of values in my_v divisible by 3 or multiples of 3 will be counted and displayed. Okay, this is what this code will do. The numbers will not be printed themselves, right? Nowhere I can see the print statement here that it is printed. No, the function either returns true or it either returns false, right? So they are not displayed over here. Let me check the chat messages. So B is 4. Is it 4? What is it? 3, 6, 9, 12. Yes, 4. Yes, I agree. 4. Yes. So the value of the count will be 4. Yes. 4 because 3, 6, 9, and 12 are the multiples of 3, they are in the vector, right? Hence, they are counted. Okay, something like that. So don't forget to put the explanation, even if you're not told to do so, because it's always counted. So whenever you put an answer, you have to always explain it, right? So usually in the beginning of the final exam paper or something, you will be told, put all the explanations to get the full score, right? So don't forget to put the explanation in. Okay, so this is it. Oh, and thankfully we finished at 1:35, right? So by the end of the class. So I have some time to talk about the final exam. So I am working, I began to work, but I once again didn't finish it. I'm only in the very beginning on the review, similar to what we had for the midterm preparation, like a list of topics that you should definitely review. So I'm working on it, working today and tomorrow, and hopefully by tomorrow night I will post it up so that you will be able to definitely go over them. But the topics I will be doing is after the midterm exam. So for the topics, let me clear all the drawings and let me stop the recording.